We talk a lot about health and performance on this show, and I think there's this really common thread that runs through it all, something we've touched on before, but not really gone deep on.
Hmm.
We always hear stuff like, you are what you eat, right? Or even, you are what you absorb.
Right.
But I
Mm.
think maybe the real story, the real key, is what your cells can actually convert into usable energy.
I like that. It really shifts the focus.
Doesn't it? Like,
Yeah.
it's not just about what goes in, it's about what your body can actually do with it at the most basic level.
Exactly. It's about that final output, that cellular energy that powers, well, everything. Every thought, every action, every feeling.
And that energy, it comes in a few main forms, right? You've got chemical energy, like all those tiny electrical signals zipping between your nerves.
Yeah.
Mechanical energy, which lets your muscles contract so you can actually move.
Uh-huh.
And then thermal energy, that keeps your core temperature nice and stable.
Right. The internal engine, so to speak.
But when that energy is missing, well, things grind to a halt.
Yeah, you really start to see the domino effect.
Big time. No chemical energy,
Yeah.
no nerve impulses, no mechanical energy. You can't even blink, forget about lifting a finger.
And the brain, forget about it.
Oh, totally. Brain cells are energy hogs. If they don't get their fix, your thoughts just stop.
It's amazing how quickly everything goes offline.
Yeah. And your immune system takes a hit too. Gets
Mhm.
sluggish, can't fight off bugs as well.
It's all connected, isn't it?
And, just to be clear, for anyone wondering about the more, shall we say, enjoyable aspects of life,
Right.
things like, erections or orgasms,
Yeah.
they need energy too. No energy, no go.
Across the board.
It really highlights how crucial this energy is for literally every single function.
It's easy to take it for granted until it's gone, isn't it?
Totally. And when we talk about energy in the body, we got to talk about ATP, right? Adenosine triphosphate,
Yeah, the big kahuna.
the energy currency of life.
Or gold standard.
And the numbers here are just mind-blowing,
Mhm.
The average cell in your body has about 1 billion ATP molecules.
A billion. In each tiny cell.
1 billion. That's 1,000 million just buzzing around in there.
It's like a microscopic metropolis.
It is. And each of those ATP molecules, it doesn't just get used once and that's it. It gets recycled.
Oh yeah, they're workhorses.
Up to 1,000 times per day.
Wow, that's efficient.
Super efficient. And when you do the math, that means you could potentially regenerate roughly your body weight in ATP every single day.
Every day. That's incredible.
Just this constant silent recycling program happening inside you.
It really puts things in perspective.
Now, different parts of your body, they need different amounts of energy, obviously.
There's
Take the brain, for instance. It's only about 2% of your body weight, but it gobbles up something like 25% of your total energy.
It's an energy hog, like we said.
Big time. And it mostly runs on glucose and oxygen. That's its preferred fuel.
Yeah, which makes sense when you think about how vital the brain is.
And how sensitive it is to any kind of disruption in that supply chain.
Exactly. It needs a constant stream.
Then you've got your heart just tirelessly pumping away.
Yeah, it never gets a break.
Never. And it burns through, get this, 6 to 8 kilograms of ATP per day.
That's what, like 13 pounds?
Yeah, more than 13 pounds of ATP every single day just to keep beating.
It's a marathon at a cellular level.
It really is. So if you think about your body like a really high-performance machine, like a Ferrari or a Formula One car,
I like that.
it's designed for power and longevity, right? But it needs the right fuel to keep running for decades.
Top grade stuff.
And that fuel isn't gasoline, it's oxygen, water, and nutrients blended perfectly to make that ATP.
The magic formula.
Exactly. And, we could spend a whole deep dive on each of those, but let's start with oxygen.
Okay, the breath of life.
The essential ingredient, right? Because you might think, well, I breathe oxygen, that's it, done.
Right, you just inhale, it does its thing.
But it's so much more than that. Oxygen, it's a reactant
It's an active participant.
in all these complex chemical reactions that happen inside your cells. And it's absolutely crucial for the mitochondria.
The powerhouse.
To actually do their job and make ATP, without oxygen, they can't function.
They go offline.
So then the question becomes, what happens if you suddenly stop breathing?
Okay, yeah, walk me through that.
Well, for the first few seconds, you're okay because your body has this tiny reserve of ATP just floating around.
Like an emergency stash.
In the cytosol, that's the fluid inside your cells, and also within the mitochondria themselves.
Just enough to keep the lights on for a moment.
Exactly, but it runs out really fast, and then your body flips the switch, it activates anaerobic glycolysis.
Now that's a mouthful.
It is, but it's basically a way to make ATP without using oxygen.
A backup generator.
Yeah, but it's super inefficient. You only get like 2 ATP molecules per glucose molecule compared to over 30 when you have oxygen.
Wow, so you're running on fumes.
Basically. And your brain, remember, it needs a ton of energy.
It's greedy.
So it starts reacting almost immediately. Focus gets fuzzy, you become clumsy, you might even feel a little lightheaded.
It's sensitive, that's for sure.
Super sensitive. And within about a minute, that tiny reserve of ATP is gone.
Uh-oh.
And that anaerobic glycolysis, it's producing lactic acid as a byproduct.
That's not good.
Nope. It makes your cells more acidic, and that messes with everything. Enzyme function, electrical balance, even the physical structure of your cells starts to get damaged.
It's like a cascade of failures.
And your heart, it tries to compensate, starts beating faster, sometimes even doing these rapid flutters, what we call tachycardia.
It's trying to get more oxygen to the tissues.
But the amount of oxygen in your blood is plummeting.
Dangerous territory.
And around the 3-minute mark, things get really serious. Brain damage starts to occur.
3 minutes. That's scary.
It can vary a bit depending on your fitness, genetics, but that's the general time frame. And some of that damage can be irreversible.
Because of that lack of oxygen.
Exactly. Your brain cells, neurons, they start dying off.
But how?
It's a process called excitotoxicity. Basically, they get flooded with these neurotransmitters like glutamate and calcium,
Overwhelmed.
and they basically burn out. Wow.
And then all those ion pumps in your cell membranes, the ones that control sodium, potassium, calcium, they start to fail too.
That's bad.
Big time. It lets even more calcium into the neurons, which activates these enzymes that break down everything.
Like a demolition crew.
Yeah, they damage your DNA, your mitochondria, everything. And on top of that, you get free radicals, and apoptosis kicks in.
Apoptosis.
Programmed cell death.
Nice.
It's like a cellular chain reaction of destruction.
All because of a lack of oxygen.
Crazy, right.
Yeah.
And if we get to 4 or 5 minutes without oxygen, that's when brain death usually starts.
There's no coming back from that.
CPR might help, but the chances are slim, and even if you survive, you might have lasting neurological damage.
So basically every second counts.
It really does. And it's just crazy to think, your brain isn't that big physically,
Right.
but it uses so much energy.
Yeah.
80 to 120 grams of glucose per day, over 3 liters of oxygen per hour, just from moderate activity.
It's a hungry organ. Makes it super vulnerable to hypoxia, which is just a fancy way of saying not enough oxygen reaching the tissues.
So I guess the takeaway here is just breathing isn't enough.
You got it. It's about optimal breathing, efficient breathing to really get that oxygen to your cells.
Right, quality over quantity.
Exactly. Okay, so that's oxygen. Now let's talk about water.
Okay, the other essential ingredient.
It often gets overlooked, because it's so simple, so readily available.
Right, we just turn on the tap.
But it's way more than just a thirst quencher. It's the universal solvent.
What does that even mean?
It means it's the medium for basically all of our biological processes. It's where everything happens.
Wow, I never thought of it like that.
And think about this. Water makes up 60 to 70% of your total body weight.
That much.
Yeah. And even more, like 75–80% of your most active organs, like your brain, liver, kidneys.
So without enough water, those organs can't function.
They can't. The whole system breaks down. It's like trying to run a car without oil.
So what happens if you don't drink enough?
Well, even mild dehydration, losing just 1–2% of your body water.
Which doesn't sound like a lot.
It's not, but it starts to impact you physically and mentally. Your plasma volume decreases, so there's less blood flow to your muscles and brain.
Makes sense.
You overheat easier because you can't sweat as well, your memory gets fuzzy, you can't focus, you're clumsier.
Wow, so those little signs of dehydration really matter.
They do. And if you get to 3–5% water loss, things get worse. Your metabolism slows down, you get muscle cramps, nausea, dizziness, you might even faint.
And that's not even that much water loss.
Nope. And your kidneys start to struggle, your urine gets super concentrated, toxins build up, you start breaking down muscle for fuel.
Your body's trying to conserve resources.
Exactly. Then at 6–10% water loss, your heart is working overtime, but it's actually less effective. So blood flow to your brain and muscles drops even more, your digestion goes haywire, and you just feel completely wiped out.
That's scary.
It is. And if you go 72 hours without water, 10–15% water loss, that's when you're in real trouble.
What happens then?
Acute kidney failure, your blood volume drops critically low, cardiovascular collapse, hypovolemic shock, and death.
So water is really that essential.
It is. And it's not just about being a passive filler either. Water is a reactant in over 1,000 biochemical reactions in your body.
Over 1,000.
Some experts think it's more like 4,000.
Hmm.
It's involved in ATP hydrolysis, protein synthesis, transporting nutrients, everything.
Wow.
And it's crucial for regulating your body temperature through sweating.
Right, you sweat to cool down.
Exactly. And each gram of sweat that evaporates takes away about zero point 0.5 to zero point 0.6 kilocalories of heat.
So it's literally carrying heat away from your body.
Yeah. And here's the thing. By the time you feel thirsty, you're already dehydrated.
Really?
Thirst is a late signal, so you have to be proactive, especially if you're exercising or in the heat.
Drink before you feel thirst.
Exactly. Okay, so we've covered oxygen, water. Now let's talk about food.
The fuel.
The building blocks, right. Because food isn't just about calories or macronutrients, it's what your body uses to make ATP.
It provides the raw material.
Exactly. And when you don't have enough food, your body goes into survival mode.
Fight or flight kicks in.
More like conserve and ration. It starts breaking down its own tissues to keep the essential functions going.
Like a controlled demolition.
In a way, yeah. So let's say you stop eating for a day, just one day, but you're still drinking water and breathing fine.
Okay, short fast.
Right. Your body first uses up its glycogen stores, that's stored glucose, in your liver and muscles.
Quick energy.
And it starts breaking down fat, too, through lipolysis. And you might see your metabolism dip a little, 5–10%, as your body tries to conserve energy.
Makes sense.
Now, after 24–48 hours with no food, those glycogen stores are gone.
Empty tank.
So your body kicks into gluconeogenesis, which is making glucose from non-carbohydrate sources like amino acids from muscle protein, lactate, glycerol.
It's getting creative.
It has to. And it also ramps up ketosis, where your liver converts fatty acids into ketones.
Ketones, those are an alternative fuel, right?
So the brain and heart, yeah, not ideal, but it works in a pinch.
So your body's really adapting.
Big time. But to do all this, it needs amino acids, so it starts breaking down muscle.
Not good for gains.
Definitely not. Now, if you go 3–7 days without food, you enter this fasting adapted state.
So the body's adjusting to the lack of food.
It is. You're getting most of your energy from fat and ketones, and the muscle breakdown slows down a bit, but doesn't stop completely.
Still not ideal.
And your metabolism drops even more, maybe 20–25%, so you feel pretty sluggish.
It's like going into power-saving mode.
Yeah. Now, if you keep going, weeks without food, your fat reserves run low, especially if you were lean to start with.
Oh.
And your body has to go back to breaking down muscle, including essential muscles like your diaphragm and heart.
So it's really a last resort.
At this point, you're losing vital organ function. You might get cardiac arrhythmias, respiratory problems, hypothermia, super low blood sugar, and your immune system is basically non-existent.
That's a terrifying downward spiral.
It is, and without intervention, it's usually fatal. And here's the key thing. Skeletal muscle is your biggest protein reserve.
So it's what your body turns to when it's desperate.
Exactly. And when it starts breaking down muscles like your heart and diaphragm just to keep your blood sugar stable,
That's a time that things are going very wrong.
very wrong. So, we see this idea of calories in, calories out a lot in the fitness world.
Yeah, and sometimes people take it to extremes.
And that can be really dangerous because if you're constantly in a calorie deficit, your body is constantly in this low energy state.
Which has all those knock-on effects.
Exactly. Your hormones go haywire, your immune system weakens, you might have reproductive issues, even your brain function suffers.
It's not sustainable.
It's not. And I worry about some of the messages we see online, these super restrictive diets that people promote.
Yeah, you got to be careful what you believe.
It's so important to get information from reliable sources. Eating well isn't just about hitting a calorie target. It's about fueling your mitochondria, keeping your muscles strong, and supporting all your body's functions.
It's about nourishing your body at a cellular level.
Exactly. So, we've talked a lot about these three elements: oxygen, water, food.
The trifecta.
But I want to ask you, what are you doing with them? Because a lot of people, they're not breathing properly, they're not hydrated enough, they're not eating the right foods.
So they're not maximizing their energy potential.
Right. They're just surviving, not thriving.
And all those little things add up.
They do. Like, if you're not breathing right, you're not getting enough oxygen to your mitochondria, and that can lead to chronic oxidative stress.
Which is basically damage at a cellular level.
Yeah. And even mild dehydration, like we talked about, it can reduce your performance by 10%, both physically and mentally.
Wow, that's significant.
And then if you're eating a lot of processed food, that causes inflammation and messes with your mitochondria too.
So it all comes back to those basics.
It does. But here's the good news. You can train your energy systems to be more efficient.
You can. Tell me more.
Yeah. Diaphragmatic breathing, that helps increase your lung capacity and gets more oxygen to your cells.
So it's not just about taking deep breaths.
Nope. It's about using your diaphragm properly and staying hydrated. That keeps everything running smoothly.
Like oiling the machine.
And eating nutrient-rich foods with all those cofactors like magnesium, zinc, B vitamins, creatine, CoQ10, that helps your mitochondria function at their peak.
So it's not just about calories, it's about quality.
Exactly. And exercise, that's a big one. It actually increases the number and efficiency of your mitochondria.
No way. So working out makes your cells better at producing energy.
It does. A trained athlete can have double or triple the mitochondrial density of a sedentary person.
That's amazing.
It is, right? So the bottom line is energy isn't just some side factor. It's the foundation of everything.
That's what makes everything possible.
Your performance, your mental clarity, your health, your longevity, it all comes back to energy. And I truly believe that you're not just what you eat, you're what your mitochondria can transform into energy.
Powerful stuff.
It is. And it comes down to a choice. You know, are you just surviving, breathing shallowly, drinking just enough water, eating whatever's convenient? Or are you thriving, breathing deeply, staying hydrated, nourishing your body with the best possible fuel?
I know what I choose.
Me too. And I
Yeah.
think when you understand how crucial energy is, that choice becomes a lot easier. So as we wrap this up, I want you to really think about your own habits, how you breathe, how much water you drink, what you eat.
Yeah, pay attention.
Because those little things, they have a huge impact on your energy levels, your health, your well-being.
Difference between just existing and truly thriving.
Exactly. So take a moment, think about those choices, and ask yourself, what can I do to shift from just surviving to living with energy and vitality?
It's a question worth pondering.
I think so. And I hope this deep dive has given you some food for thought, no pun intended.
I think it has. It's been a fascinating conversation.
Thanks for joining me. It's always a pleasure to dive into these topics with you.
Likewise, until next time.
Until next time.